Hello everyone. In this video, we will be studying multiplication and division using fractions. You'll be happy to learn that these two operations are easier than addition and subtraction. However, they are less intuitive. We will be using the basic concepts of fractions, so you may want to review video number 10, Introduction to Fractions. If you are interested in learning about addition and subtraction of fractions, please take a look at video number 11. I will also be using some of the arithmetic rules I discussed in video number 6, so this is another video that may be helpful to review. I will stick to positive fractions in this discussion. This is to make sure that you understand the basic concepts before we bring in the complication of dealing with negative fractions. In the next video, I will discuss arithmetic operations using negative fractions. When I say that multiplication and division of fractions is less intuitive than addition and subtraction, this is what I mean. We are used to multiplication increasing the magnitude of a number. For instance, when we multiply an integer by 2 or 3 or 4, we get progressively larger numbers. This becomes our intuitive understanding of multiplication. But when we multiply a number by a fraction which is less than 1, that is, a fraction where the numerator is less than the denominator, for instance 2/3, we get smaller numbers. Before I go further with the discussion, I want to refresh a concept we have discussed before and bring up a new concept. The concept I want to refresh is that we can write integers as fractions simply by making the integer the numerator of a fraction with a denominator of 1. This should make sense to us. Remember that the denominator of a fraction represents how many pieces make up a whole unit, and the numerator tells us how many pieces we have. So using my pizza math, the fraction 2/1 means that each pizza is comprised of one piece. That is, we didn't have to cut it into smaller portions. Each piece is one whole pizza, and we have 2 of those whole pieces. That is, we have 2 whole pizzas. The new concept I want to bring up is that of the reciprocal of a number. In the English language, the term reciprocal means to give or do something in return for something. In math, the reciprocal of a fraction is a number where the numerator and denominator are flipped. For instance, the reciprocal of 2/3 is 3/2, that is, 3/2. The reciprocal of 3/4 is 4/3. We can talk about the reciprocal of an integer like 3, since we can express 3 as the equivalent fraction of 3/1, and then flip the result to get the reciprocal of 1/3. The reciprocal of a number is the same as the multiplicative inverse that I discussed in video number 6. In other words, a number multiplied by its reciprocal will always equal 1. Here's the reason I bring all of this up. In video number 3 on negative numbers, we learned that subtraction is an opposing operation to addition, and that subtracting a number is equivalent to adding a negative number of the same magnitude. For instance, 4 minus 3 is equivalent to 4 plus -3. In a similar way, division is the opposing operation to multiplication. Dividing by a number is equivalent to multiplying by its reciprocal. So, if we are going to have a pizza party, and you're going to bring 2 pizzas, and I tell you that I'm going to bring half as much pizza as you, then that means that I am only bringing 1 pizza. Mathematically, we can write the equation like this. 2 times 1/2 equals 1. But I can also write it like this. 2 divided by 2 is 1. So dividing by 2 is the same as multiplying by 1/2. Dividing by a number and multiplying by its reciprocal are equivalent. In practice, multiplying fractions together is quite simple. You simply multiply the numerators together to give you the new numerator, and multiply the denominators together to give you the new denominator. So when we multiply 2/3 times 4/5, the resultant numerator is 2 times 4, which is 8. The resultant denominator is 3 times 5, which is 15. 8/15 is in its simplest form, since the numerator and denominator do not share any common factors. There is often a trick we can use to make things easier. Oh, for goodness sake, is this the fraction fairy again?
Did I hear you say trick? There are no tricks in fractions. We are playing games here. This isn't Halloween. fractions are a reputable branch of arithmetic.
When I say a trick, I mean an easier way of finding the correct answer.
Well, if that is what you mean, then that is what you should say. Be precise.
I think you're being a little too sensitive.
Me? Sensitive? Do we have to have another discussion about respect?
No, thank you. I remember how our last discussion ended. I think my ears are still ringing.
Very well then. Goodbye.
So, in the interest of self-preservation, let me phrase this precisely as suggested. There is often a way in which we can address multiplication and division problems, which help us more easily come up with a simplified solution. How's that? Good. Suppose that we have a problem like 2/3 times 3/5. From my previous discussion, we would find the answer by multiplying 2 times 3 equals 6 for the numerator, and then 3 times 5 equals 15 for the denominator. The fraction of 6 over 15 is not simplified since both 6 and 15 have a factor of 3. To simplify it, we would divide both the numerator and denominator by 3 to give us a final answer of 2 over 5. But notice that the 3 I factored out of the numerator and denominator was in the problem from the very beginning. I could have factored out the 3's before doing the multiplication. That would save me time and reduce my chances of making an error. You might ask what allows us to factor out the 3's in the numerator and denominator. That's a good question. Remember that we have to follow the rules or laws of arithmetic, so everything that we do has to be allowed by those rules. In video number 6, we covered the rules we need for this discussion. The commutative law of multiplication allows me to switch the order in which I multiply two numbers together. In this case, the numerator is 2 times 3. I can write this equivalently as 3 times 2 using the commutative law of multiplication. Now my expression is a little bit different. It is equivalent to 3 over 3 times 2 over 5. But 3 over 3 is simply equal to 1. My expression is now 1 times 2 over 5. 1 is the multiplicative identity. When you multiply any number by 1, you simply get that number. So 1 times 2 over 5 is simply 2 over 5. With a little practice, this method of multiplying fractions will definitely save you time. I don't have to go through the application of the commutative law of multiplication and the use of the multiplicative identity each time. I simply become comfortable with the fact that I can do this according to the rules of arithmetic. In a sense, I guess it's like brushing your teeth. You know how to do it right, but after you do it for a while, you don't even have to think about it. You just do it.
Hey, buddy, can you do a little bit better with your, what do you call them, analogies? Yeah, analogies.
Sorry.
We're dying here. Just saying. Brushing your teeth? Sheesh.
Okay. The point is that when I take this approach, I don't have to multiply the numerator and denominator by a number that I am going to have to later factor out when I try to simplify the fraction. Let's look at another example. Let's multiply 2 over 5 by 5 over 7. Again, the solution is found by multiplying the two numerators together, 2 times 5, to create the resultant numerator, and similarly multiplying the two denominators together, 5 times 7, to get the resultant denominator. Before I do the multiplication, though, I notice that I have 5 in both the expression for the numerator and the expression for the denominator. I can factor both of those 5's out, and the answer is simply 2 over 7. If I don't notice this and do the multiplication, it's not a huge deal, it's just a little extra work. I would get 10 over 35. This fraction is correct, but not in its simplest form. And remember that normally we try to express fractions in their simplest form. I would have to divide both the numerator and denominator by 5 to get the simplified fraction of 2 over 7. It's the same answer. Multiplying mixed fractions isn't a lot harder. I simply convert the mixed fractions to improper fractions and then multiply as before. Let's try an example. What is 2 and 2/3 times 3 and 1/4? Remember that you convert mixed fractions to improper fractions by multiplying the denominator by the integer part of the mixed fraction and adding the numerator. This gives you the new numerator, and you keep the same denominator. So for 2 2/3, multiply the denominator of 3 by the integer 2. You get 6. Then add the 2 from the numerator. You get the new numerator of 8. The denominator is 3. For 3 1/4, you get the improper fraction of 13/4. Our multiplication problem is now 8/3 times 13/4. Notice that I can express 8 equivalently as 2 times 4. Now I have 4 in both the numerator and denominator. My solution is 26/3. If I had not canceled the 4 from the numerator and denominator, then I would have got 104/12. This is correct, but not simplified. I would have to divide both the numerator and denominator by 4 to get the equivalent simplified fraction of 26/3. The answer of 26/3 is an improper fraction. As you probably know by now, the best way to add, subtract, multiply, and, as you will learn, divide fractions is to express them as improper fractions. So if I'm going to use this fraction in further calculations, I would normally leave it as an improper fraction. If I have no further calculations to apply to this fraction, I will normally use my long division to express it as the mixed fraction of 8 2/3. Are you ready to try an example on your own? After I give you the problem, please pause the video until you have worked out the solution, then resume the video. Here is the problem. What is 1 5/16 times 8/15? Please pause the video now while you try to solve this problem. Let's see how you did. 1 5/16 is a mixed fraction, so the first step is to convert that to an equivalent improper fraction. 1 times 16 is 16, plus 5 is 21. The improper fraction is 21/16. 8/15 is not a mixed fraction, so we are ready to multiply the two fractions together. The new numerator will be 21 times 8. The new denominator will be 15 times 16. Performing this multiplication and then simplifying the answer looks like it's going to be a little bit ugly. We can do it, but it won't be a lot of fun. At least it isn't my idea of fun. But we have an opportunity to do a lot with this fraction before we do our calculation. I can express the 16 in the denominator as 2 times 8. This allows me to factor out an 8 from both the numerator and denominator. That helps. I can also express the 15 in the denominator as 5 times 3, and I can express the 21 in the numerator as 3 times 7. This allows me to factor out a 3 from both the numerator and denominator. Now we have managed to control the ugliness for the most part. We are left with a numerator of 7 and a denominator of 10. Since this fraction is already in its simplest form, we are done. How did you do?
Nailed it!
Very good. Let's try to get a handle on dividing fractions now. Remember that I said that dividing by a number is the same as multiplying by its reciprocal. That's exactly what we're going to do. Let's do an example. What is 4/9 divided by 2/3? Instead of dividing 4/9 by 2/3, we're going to multiply 4/9 by the reciprocal of 2/3. I get the reciprocal of 2/3 by simply flipping the fraction. My problem is now 4/9 times 3/2. I can replace the 4 in the numerator by the equivalent expression of 2 times 2, and then factor out one of the 2's in the numerator with a 2 in the denominator. Similarly, I can replace the 9 in the numerator by the equivalent expression of 3 times 3, and factor out one of the 3's in the denominator with the 3 in the numerator. I am left with an answer of 2/3. Here's where people sometimes make a mistake. When you have a division problem, you have to flip the number that you're dividing by. This number is called a divisor. You can't flip either of the fractions. It has to be the divisor. There is no commutative property of division as there is for multiplication. Are you ready to try a problem of your own?
Absolutely, young man.
Okay, good. As we always do, pause the video after I've given you the problem, work out the solution, and resume the video when you are done. What is 3/10 divided by 3/5? Please pause the video now. Let's go over the answer. Neither of these numbers is a mixed fraction, so we don't have to worry about converting them to improper fractions. We can simply flip 3 over 5 to its reciprocal of 5 over 3, and then multiply the fractions together. I notice that both the numerator and denominator have a common factor of 3, so I can cancel the 3 in both locations. I also notice that 10 can be replaced by the equivalent expression of 2 times 5. When I make that replacement, I have a 5 in both the numerator and denominator that I can factor out. Some of you are going to get stumped here. I'm left with a 2 in the denominator, but what happened to my numerator? Well, it is possibly a little unfair of me to present you with a problem like this without talking about it first, but you're going to have to handle unexpected problems. Uh-oh, here we go again.
You are quite mistaken. You're not possibly a little unfair. You are in fact most decidedly and utterly unfair, to the point of being capricious.
Capricious?
Indeed, yes, and I'm the judge of fairness. After all, I am a fairy. We fairies are known best for our fairiness.
Fairiness? I don't suppose it'll do me any good to argue about this.
Indeed not. Don't become more irksome than you already are. Simply apologize and end this tiresome endeavor. Call a math lesson.
Okay, I apologize. I'm sorry, everyone, for my capricious behavior. Let me finish this problem and then wrap things up. The long and short of things is that when we factor out numbers from both the numerator and denominator, we are not left without anything. When I say that I am factoring a 3 from both the numerator and denominator, I'm converting the fraction 3 over 3 to 1. The 1 is normally ignored since it is the multiplicative identity and effectively disappears when it is multiplied with another number. But it still exists. I used to tell my students that it is an invisible one. It only appears when there is nothing else left to express the value of the numerator, in this case. So the answer is 1/2. If you're skeptical of that explanation, then do the multiplication without factoring out the 3 and 5. You would end up with 15 over 30. This is unsimplified. To simplify it, we would divide both the numerator and denominator by 15. 15 divided by 15 is 1. 30 divided by 15 is 2. We are back to our solution of 1/2. So we have completed another lesson. If you're struggling with any of this, then I recommend that you review the problems. It might also be helpful to review videos number 6 and number 10. In the next lesson, we will be discussing negative fractions. Have a great day, everyone.
We hope to see you at Veterans Upward Bound very soon and recommend a friend.